There are three independent hydraulic systems on the 757, designated left, center, and right. The left system supplies hydraulic pressure to the flight controls, left thrust reverser, flaps and slats, landing gear, nose wheel steering, and the alternate brakes. If required, a power transfer unit or PTU supplies pressure to the flaps and slats, landing gear, and nose wheel steering. The center system also supplies hydraulic pressure to the flight controls. The right system supplies hydraulic pressure to the flight controls, right thrust reverser, and the normal brakes. The reserve brakes are supplied pressure only by the right system's electrical pump. Any single system will provide sufficient flight control for all three axes. The left, center, and right hydraulic systems have independent reservoirs. Each reservoir is pressurized by bleed air to ensure positive fluid flow. The hydraulic fluid levels are displayed on the ICAS status page. A normal level is 1.00 or 100%. An RF, which stands for refill, is displayed when the reservoir requires additional hydraulic fluid. Each reservoir has a standpipe for the normal supply line in order to maintain reserve fluid in case of a leak. The reserve fluid in the left system is used during PTU operation. The reserve fluid in the center system is used during ram air turbine or RAT operation. And the reserve fluid in the right system is used for the reserve brakes. Each hydraulic system is pressurized by two pumps. The left and right systems use an engine-driven pump and an electrical pump. The center system uses two electrical pumps. For certain abnormal conditions, there are two backup pumps provided: a ram air turbine or RAT and a power transfer unit or PTU. The hydraulic control panel, which contains the controls and indications for the hydraulic systems, is located on the overhead panel. Click on the forward arrow when you are ready to proceed. Let's now look at normal operations. The engine-driven pumps are the primary pressure source for the left and right systems. The pumps are controlled by on-off switches. With the engine running and the switch selected on, the pump supplies fluid under pressure to the system. Selecting the pump switch to off depressurizes the pump. Normally, the switch remains selected to on. The electric pumps provide additional pressure to the left and right systems and are also controlled by on-off switches. Both pumps operate continuously when selected to on. The center system electric hydraulic pumps are controlled with on-off switches. Selecting either pump on provides pressure to the center system. Let's now discuss abnormal operations. In the event of dual engine failure in flight, the RAT located aft of the right main gear will automatically deploy. The RAT's hydraulic pump provides pressure to the center system to operate the flight controls. The RAT switch, located on the overhead panel, has an unlocked light which indicates the RAT is not locked in the stowed position. The associated ICAS advisory message will also be displayed. The green pressure light will illuminate if the rat is supplying adequate pressure. The minimum airspeed to ensure proper rat operation is 130 knots. The rat can also be deployed at any time by pressing the rat switch. Once deployed, the rat can only be restowed by maintenance personnel. The system pressure light, caution alert, and associated ICAS message appear when a system's pressure is low. In this example, the left system has lost pressure. The reservoir light illuminates and the associated ICAS message appears if either a low reservoir head pressure or a low reservoir quantity is detected. In this example, low head pressure is detected in the center system reservoir. In this example, the center system reservoir quantity is low. The pump pressure light illuminates and the associated ICAS message appears when the affected pump's output pressure is low or the switch is selected to off. In this example, the right electric pump's output pressure is low. The overheat light illuminates and the associated ICAS message appears when the affected hydraulic pump's temperature becomes excessive. In this example, the right electric pump has overheated. The PTU is automatically activated whenever the left engine pump's output pressure is low, or the left engine is shut down and the right engine is running. For example, with the right engine running and the left engine's pump's pressure low, the PTU automatically activates. This condition will ensure flap, slat, landing gear, and nose wheel steering operation. There is no indication of automatic PTU operation. A PTU switch located on the overhead panel provides for manual override of the automatic activation circuit. This switch is for maintenance use only. Click on the forward arrow when you are ready to proceed. Let's complete the lesson with a look at 767 differences. On the 767, the center system provides hydraulic pressure to the flaps and slats, landing gear, nose wheel steering, and alternate brakes. The reserve brakes are also powered by the center system. On the 767, only the center reservoir has a standpipe and reserve fluid. The left and right reservoirs do not. The reserve fluid is used for reserve brakes and nose wheel steering. The left and right systems are pressurized by an engine-driven pump and an electric demand pump. The electric demand pump augments the primary pump when system pressure is low. The pump is controlled by a 3-position switch. With the switch selected to off, there is no pump output. In the auto position, the pump will automatically operate when primary pump pressure is low. In the on position, the pump will operate continuously. The auto position is the normal position for flight. The center system uses 2 electric pumps and an air-driven demand pump, or ADP. The ADP is driven by the pneumatic system and augments the center system's pressure. The ADP is controlled by a 3-position switch. The off position will deactivate the pump. In the auto position, the pump's air supply valve opens automatically during flap operation, gear retraction, and ground spoiler deployment, or when system pressure is below normal. With the selector in on, the pump will operate continuously. The auto position is the normal position for flight. The ADP pressure light illuminates and the associated ICAS message appears when low pump output pressure is sensed. The reservoir light illuminates and the associated ICAS message appears to indicate low reservoir quantity only. Head pressure to the reservoir is not monitored. The hydraulic motor generator, or HMG, is driven by center hydraulic system pressure, supplied by the air-driven pump, or ADP. With the loss of both the left and right main AC buses, the ADP will automatically operate to pressurize the HMG, provided the pump switch is selected to auto. To ensure the HMG will receive adequate hydraulic pressure, the hydraulic flow to the flaps and slats is mechanically reduced. This reduction will result in increased flap and slat operating times. During landing gear retraction, HMG operation will be interrupted because gear retraction requires more hydraulic pressure.